classwork's on the board. Go ahead and take just a few moments to analyze and graph this conic. Pause the video, and then when you're finished, go ahead and resume the video and we'll go over it together. All right, well, students in here are finished with the classwork, so let's take a look at the problem here. What's the first thing we had to do, Quentin?
Divide everything by 36.
Because we want to set the equation equal to 1. And there's only 2 times we set equations equal to 1. We don't do that for every conic. Which conics do we set equal to 1, Jamie?
The ellipse and the hyperbola.
Ellipse and hyperbola. So how do we know this is an ellipse or a hyperbola?
There's a difference of...
Okay, so the difference specifically tells us
that is a hyperbola.
Hyperbola, but we could have a minus and it not be a hyperbola. We've got a minus and...
There's a difference.
They're both squares, right? So the 2 squares with the minus together tells us hyperbola. That's why we set equal to 1. Again, as we think of a test coming up in just a couple of lessons, we want to approach each conic in the way it needs to be approached. And obviously, we'll be reviewing that in the days ahead. For now, we're focused on a quiz coming up over hyperbolas. And so, yeah, we'll divide everything by the 36, set it equal to 1 to get what?
X squared over 1 minus y squared over 4 equals 1.
All right, so at this point with the analysis, the first thing we want to determine is where is the origin of our hyperbola? Quentin?
0, 0.
It's going to be at 0, 0. Then we want to determine the which axis is going to have the transverse axis along it. Jamie?
The x.
The x-axis. Then we want to know, well, how long is this transverse axis, Quentin?
1 each.
1 each. A total length of 2, but 1 each direction from the origin along the x-axis. Then the other axis really doesn't get used for much, Jamie.
The conjugate.
Conjugate axis is going to be how long?
2 each.
2 each, so a total length of 4. And really, the purpose of these 2 axes, especially the conjugate axis, though, is simply to get us the
rectangle of the hyperbola.
The
fundamental
rectangle of the hyperbola. And the reason we need said fundamental rectangle of hyperbola is so we can get the asymptotes. Then we also need to know, because transverse axis tells us where the vertices are. They're going to be the ends. Then outside the vertices, Jamie, we have actually the 2 points that define the hyperbola.
The focus.
The foci, right? The foci, because remember, the hyperbola is defined as the locus of points having a constant difference of distances from those 2 foci. And what is the focal length?
0 to 5, which is 2.2.
Now, important to remember this focal length. Is it measured from the vertices?
No.
They lie outside the vertices, but it's not measured from the vertices, class. It's measured from the origin. Just as the foci are measured from the center of an ellipse, it's the parabola where vertex is measured from, or where focus is measured from the vertex. So again, keeping all these things straight is going to be the fun challenge for us in the review lesson coming up later. And then the focal chords, the latera recta. We want to know how big is each half of the latera recta, and we get what here, Quentin?
4.
4, which is pretty long. Okay, so we're going to have pretty flat hyperbola here. Starting at 0, 0, along the x-axis, we'll go 1 in each direction. We'll go up and down 2 to get the corners of the fundamental rectangle here. Straight edge, very helpful. Make sure you have one of those ready to go, both for the quiz coming up later this hour, and then certainly for the test coming up in a couple more lessons. I remember the focal length 2.2 from origin, yeah, so 2.2 be about here, and then from there up and down 4, which puts us really close. And here my asymptote missed a little anyway, which makes it end up being even closer than it should be. And remember, from the vertices, we'll go through the ends of the latera recta, just a little bit of a curve approach, but don't touch. A little bit of that curve approach, but don't touch. And get a hyperbola like that. How did your hyperbolas turn out? Any questions on this? Again, just for sake of review, what's the equation for the focal length, class?
Square root of a squared plus b squared.
Good. Now remember, the ellipse, you subtract the squares. Hyperbole, you add the squares because you want a bigger focal length. And then the half ladder rect is actually the same for both of them.
B squared over A.
Just the b squared over a. The difference is the b squared is the one with the negative, and the a is the square root of the one with the positive. Where on the ellipse, remember, the b squared is the smaller number, and the a is the square root of the bigger number. So again, just keeping those little details straight, I suppose. Also, for both the ellipse and the hyperbola, again, a lot of similarities there. The eccentricity can be found with what formula? It's not part of the graph, but
C over A.
C over A. And so the C here we said is that square root of 5. We said A is the 1 each. So 2.2 eccentricity, pretty flat, but not a terrible eccentricity there. Questions? All right, turn your textbooks, if you would, to page 252. Page 252. Take a moment, do 10G. 10G on page 252. check your algebra first of all. How'd we do? Uh-oh.
See what I showed down?
What happened?
So for some reason, like I couldn't find the binomial squares, and I was like, okay, 4 times -5 is 20. I need to do -20 on the other side.
So you went all the way to the binomial squared before you
Right.
added to the other side. It's
Right.
got to be when you complete the square that you then add to the other side. Okay? Quentin? On the right track. So Jamie, where should the origin of my hyperbola be?
It should be at 0, 5.
0, 5. Which axis has the transverse axis?
Y.
And how big is each side of the transverse axis?
5.
5. Ooh. So, a little bit more room than I was giving myself here. Oh boy. Yeah, I'm beginning to think I should have lowered my my x-axis.
That's what I did.
Problem was I didn't analyze it first. I just drew the thing and thought, I'm sure I'll get away with it. Nope, not getting away with it on this one. Conjugate axis, Jamie?
2.
Just 2. This gives us a very tall fundamental rectangle. But because the transverse axis is the long one, we're going to end up with not a super flat hyperbola, but a very curved hyperbola. What's the lowest, well, it's not actually, you can't even have this eccentricity, but what is the, quote, lowest eccentricity a hyperbola could have, class?
1.
1. Now, granted, it won't actually have the 1. That would make it a parabola. But just above 1, I guess, is the better answer, but that's not the way I phrased the question. What about the focal length here, Jamie?
Hopefully square root of 29.
Which is about 5.3?
5.4.
5.4. So the foci fall just outside. By the way, that means that the eccentricity here is going to be the square root of 29 over 5. 5.4-ish divided by 5 ends up giving us what eccentricity?
1.1.
About 1.1. Again, this is about as low an eccentricity as we're going to see. What about the half ladder erecta here?
0.8.
0.8. So really short lattice rectum here. Obviously, again, short lattice rectum here. And that's going to get a very tight parabola or hyperbola down here. And then the other branch, I'm not going to be able to draw very much of it because I ran out of room. And maybe that's just as well. Again, often with the hyperbola, less is more. And so something like that is what we should have. Questions on 10G? So just a reminder, complete the square, do the multiplication, add to the other side before the binomial squared. All right, one more, and then I think we'll be ready for the quiz. Let's do letter H. Still there at number 10. Number 10, but letter H now as we wrap up. revise this one first. Learn my lesson the hard way. How'd you do with your algebra? All right. Not too bad of a shift this time. The masterpiece is finished. Just kidding. Anyway, I'm a little obsessive, I suppose. So, do we translate the center at -3 up 2? Okay. Transverse axis 4 on each side, total length 8. Conjugate axis 10 total, 5 on each side. So big fundamental rectangle, big gap between the two branches. Focal length comes out to 6.4, which is about 2.4 past the vertices, and then out 6 1/4 in each direction to get to the ends of the latera recta. A very long latera recta, but because you've got such a big focal length as well, that gives you a little bit more room to go out there. You have something like this then. All right. Questions at all on hyperbolas, or do you feel like we got this? All right. If you're watching on YouTube, I'm going to end the video here in just a moment after I give out the quiz. So if you want to make note of this, your homework is a handout that's in the description of the video. So look in the description of the video. You'll see a link to the handout. Take care of those problems. We'll be going over those in our next lesson. At this point, though, let's go ahead and clear your desk, except for a clean sheet of paper and a pencil and a calculator. Clean sheet of paper, pencil with the good eraser. You'll want the good eraser, and a calculator. Pencil, eraser, calculator, paper. You may want the extra paper to do some work on. There's a fair bit of algebra involved with hyperbolas, obviously, and not a lot of room on the quiz itself to work. This is quiz 41. When you get your quiz copy, put your first and last name in up at the top of the quiz. There's not a blank that says name, but you'll see just a little space there at the top, like the last couple of quizzes we've had. Put your first and last name at the top and today's date, which is 4/14/22. 4/14/22, today's date. All right, you'll notice the 6 pieces of analysis for each, and then you'll graph each as well. Again, as needed, do your work on paper, but if you would, write the answers directly here on the quiz copy, and of course, do the graph on the quiz copy. Any questions before we begin? All right, you may get started. We'll end the YouTube video here.